Hey guys, welcome to video 4.2. We're going to talk about ionic compounds. By the end of this, you should be able to construct a Lewis dot diagram for ionic compounds and explain the lattice structure of ionic compounds to determine which ionic compounds have the greater lattice energy. So just a quick review on ionic bonds. If you remember, they're transferring electrons, and it's going to deal with metals and nonmetals. They're going to have a high melting point, high boiling point. They're going to be soluble. They conduct electricity, and for the most part, they're all going to be solid. So right here, we're going to find the ionic formula. And the first thing we need to do this is let's look at number one. It's potassium and bromine. We need to know the charge for these. So we know that potassium has a +1 charge and that bromine has a -1 charge. So when we write out the ionic formula for it, it's just going to be KBr, and that is it. That is a balanced ionic formula for potassium bromide. The next one is magnesium and chlorine, and magnesium has a +2 charge, chlorine has a -1 charge. So when we write this out, they need to balance each other out. And to do that, we're going to need, for every 1 magnesium, we're going to need 2 chlorine, because that 1 negative charge needs to balance out that cation's +2 charge. The next one is sodium and sulfur, and sodium has a +1 charge. Sulfur has a -2. So if we write the ionic formula for this one, we need to write Na2S. Same thing as one before. Since sodium has a +1 charge, we need to balance out that -2 on the anion, and so we'd write it out as Na2. So for every 2 sodium, we have 1 sulfur. And the last one is calcium and sulfur. Calcium has a +2 charge and sulfur has a -2 charge. So they're going to go ahead and they'll cancel each other out, and we'll just write CaS, and that would be the correct ionic formula for that. The next one is Lewis dot structures. You should go ahead and watch my next video when you're done with this video, and I'll show you how to draw Lewis dot structures. So which subatomic particle is involved in all this bonding? What's controlling all this? And the answer is it's electrons. It's just the electrons. The protons do help determine the mass and the positive charge of it, but it's the electrons that are being changed around. So the geometry of ionic crystals. Why does table salt look like a crystal? And it has to do with its lattice structure and how they alternate. If you look here, you can see that the different atoms are alternating within this cube, this crystalline structure. Lattice energy is the energy released when gaseous ions create a solid ionic compound. And we use a law called Coulomb's law. It can be used to calculate and compare the lattice energy of compounds. And we have a formula to calculate it. And lattice energy is equal to a constant, which is Coulomb's constant. We'll look at that in our next video. The charge of the first ion by the charge of the second ion divided by the distance between those ions. And we can find those distances in our book, in our notes, and on periodic tables. Some scientists have already calculated all this for us. We just need to know this formula and to be able to determine what's going to have the most amount of energy. So there's that formula again. And compounds with ions that have higher charges, like a +3 or +1 versus a -3 or -1, have a larger lattice energy. It's due to more electrons being transferred, creating a stronger ionic bond. So since there's more electrons involved, that bond's going to be a lot stronger and harder to break. Compounds with ions that have smaller radii have larger lattice energy, since the ions can get close together, creating a strong ionic bond. So the closer they are, the stronger they're going to become. So what would happen to the lattice energy if the radii was tripled, if they were removed farther away from each other? And what would happen is the lattice energy would decrease. It would be easier to pull them apart if they were farther away from each other. If the charges were doubled. So what would happen if the charges were doubled? If the radii triples, then the lattice energy decreases. And then the third one, what is if the radii was halved? What if they were closer together? All of our atoms were closer together. Then the radii halves, then the lattice energy would double. So here we're going to look at lattice energy. Which compound has more exothermic lattice energy? And to do this, we need to use that formula to determine each one. So here, sodium chloride is going to have a more exothermic lattice energy. Here, magnesium chloride will have more lattice energy. Lithium fluoride, magnesium oxide, and sodium oxide. If you watch my next video, you'll see me calculating some of these for you. Look for large charges, and you want to have a small radii. So hopefully by this video you now understand how to construct a Lewis dot diagram. If you don't, watch my next video. Explain the lattice structure of ionic compounds and determine which ionic compounds have the greater lattice energy.